Last week, I set forth to code the worst calculator of all time. Using some techniques I picked up from my limited coding knowledge, I clashed with my friend Akash in an attempt to prove I was the worst coder. Our battle was legendary. Akash created a calculator with very little calculation knowledge, and I made a mess of SQL and the Python coding language. That video got a lot of views, and like anything that's popular, it needs an arguably worse sequel. As I read the shareholder opinions, which you might know as the comment section, one thing became immediately clear to me. You all have some terrible ideas. You filled the comments with suggestions on how to make the code worse, how to absolutely destroy my computer and make it wish that binary had never been invented. From mathematical to logical catastrophes, you shareholders made it clear that Flingboard Research Incorporated had plenty of room to grow. Today, being the savvy tech genius entrepreneur I was born to be, I repurpose your ideas to create an even worse calculator. Join me as I adventure into the depths of what is possible in programming and, once again, unleash a behemoth unto the world. So, where do we begin? Implementing any of your ideas with the SQL recursion from last video, watch it after this if you haven't already, would actually be torturous. That's why I decided to completely scrap the old calculator and begin building from scratch. First, Unspeakable Creature suggests, at this point, you should have created lookup tables for known results and speed up the process. I think that's a horrible idea, which means it's a great idea. Instead of using the operators provided by Java, plus, minus, times, divide, what if we instead just pre-computed the results and stored them in a giant map? Think about it this way. We create a map with keys and values. We store a 3-element integer list for the key. This integer list has A, our first number, B, our second number, and C, a number representing the operator. Then, for each A and B value from 0 to 99, we compute the result. This creates a map that stores every possible combination of outcomes from 0 to 99 for each operator, which, if you want to be a nerd and do the math, is 4 times 100 squared, or 40,000 elements. While coding this one, I ran into the dreaded divide by zero error. Instead of, fixing it, I just used a try-catch statement to filter these out. Great. Who's next? Bad Chess 56 provides the genius idea. You could have taken recursion so much further. Call repeated addition for multiplication. I agree. If you really think about it, multiplication and division are really just adding and subtracting a bunch of times. The equation 3 times 4 is just adding 3 4 times. This allows us, as the genius coders we are, to use recursion once more. If we create a function that returns a plus you keep going until b equals 0, we can turn what would be a simple multiplication problem into a time-sensitive nightmare. Having implemented this, I want to discuss one of my favorite concepts in computer science. Big O. I love Big O. For those who don't know, Big O is the representation of the time complexity of a project. In English, okay. A normal Big O notation looks something like this. This is O of n. Pretty much, for each n element the computer must check, it requires one more unit of time. This unit of time isn't really a set unit, and is completely dependent on your computer's processing power. When we graph the Big O of different programs, we can see how certain algorithms with better time complexity do better at certain tasks. Something like bucket sort, if you don't know, don't ask, I don't really want to dive into sorting algorithms in this video, has a time complexity of O of n. Algorithms like binary search have a time complexity of O log n. Then we get to slower programs. Something like selection sort has an O of n squared because it needs to traverse a list twice for each element. Our program currently sits at a nice and gargantuan O of n cubed. This, by any metric, is completely terrible, especially since this is just building the lookup table, not even searching it yet. See, our program first computes each value from 0 to n for a, but each of those values also have a b value from 0 to n. This is n squared. Then, by adding our recursion, it must traverse from 0 to a once more, making this program n cubed. As a little side note, I also decided to implement division recursion, basically subtracting and counting the amount of times we can subtract before we reach 0. But I once again forgot to include a check for dividing by 0. Damn, why did I even bother including this to-do there? This caused a Stack Overflow error when our program began to recurd without subtracting any number. Recurd? Recurse? Yeah, you get it. Once again, I opted to not just add a boring check for this case, but to do something which I don't think any programmer has ever done. Catch Stack Overflow. If you're a senior dev or know anything about computer science, you just shuddered. It's kind of a benchmark in programming that you never catch an error, you only catch exceptions, and especially with something like Stack Overflow error, this should never be caught. What catching this error does is pretty much tell Java to simply ignore it and continue going, which doesn't actually reset the stack, but just keeps it in the background, so that our memory is still being taken up, but our program continues to run. Very bad. But very good. I don't really know if catching all these Stack Overflow errors adds to our time complexity, but it definitely takes up a lot more time and space than it needs to. That was a headache and a half. Let's see who's next. Okay, I'm just gonna breeze over that one. Anyways, Tokivo says, "This is clearly time inefficient. Thanks, I didn't notice. It would be so much better to do this threaded to optimize away the wait time." I agree. Ask any programmer and there is likely a 90% chance that they hate multi-threading. I hate it too. Don't worry. Instead of filling our hash map one at a time, why don't we just complete it on separate threads? Psst, if you don't know what multi-threading is, watch this video. Using one Java program is honestly way too space efficient, and it would be much better if our program could take up as much space as possible. That's why I put each of our hash set fillers on its own thread. This creates a mess that nobody can understand. This also created a pretty funny error called a race condition error. It's time to learn with Flingbore. See, the static keyword used here and here in Java denotes the fact that a member, which is a variable method blocker class, is part of the class itself. When you write the main method of your Java program, you write public static void main string args. Static means this code runs as soon as the class is loaded. When we combine that with threads, we create a nightmare where things are running before we're even ready for them. This staticness is great until you're doing something idiotic like we are. Adding everything to our hash map statically while also trying to access the hash map creates a weird limbo state where data is being stored while also not being there yet. This is called a race condition and is a terrible mistake that programmers make all the time. You may be screaming at your computer, "Just put the hash map in the main." But come on, that's really boring. Instead, I just decided to make our code wait for 1 second and pray that our computer can finish the hash map before we access it. In the industry, this is known as eventually consistent programming. That's a good one. That was fun. Let's see what else you came up with. Joella So 3218 says, "You came up with this but misusing completely nonsense variable names? First of all, buddy, language. And second, yeah, you're right, that was a big miss." I want to address this comment in tandem with another I saw. TT Thoma said, "When you make code so bad, you're actually just inventing obfuscation." I really like this comment. See, in the real world, some coders actually intentionally make their code unreadable. And no, before you ask, there isn't any Arby's on the line, surprisingly. Let's say you're a programmer, creating malware or maybe something more morally good, and you don't want anybody to change it. Pesky people called reverse engineers really want to reverse your code from its run data back to its original form. Think about it. If you name variables readable names and an engineer is able to reconstruct your original code, it is that easy for them to change the variable to something else. However, if you use horrible variable names, the reverse engineer will have little to no idea what a function named $$ from the things class is really supposed to do. By renaming every variable in our code to something terrible, we truly make our code that much worse. Finally, and by far one of the most popular suggestions, was to scrap conventional languages entirely and use an SOLang. What is an SOLang, you ask? An SOLang, sometimes called a weird language, is a coding language designed to push the boundaries of what is possible with coding. Some favorites of mine include Chef, where you literally write a cooking recipe to execute code. Piet, where you draw abstract art that represents code. Malboj, named after the 8th circle of hell, which is its own horrible can of worms. Whitespace, which uses only whitespace rather than any readable characters. And finally, Brain. What, I can't say Brain, or as I'll be calling it BF, is a language that has only 8 distinct usable characters. You heard me right, 8. In my opinion, BF is the best SOLang. I think that many people view BF as just a meme language, maybe because it swears in its title, but it's so much more than that. I would legitimately argue that BF is a work of art. Let me tell you a little story. BF was created by a Swiss student, Urban Müller, as an attempt to create a language with the smallest compiler. The Java development kit is around 36 to 38 megabytes. The C++ compiler, CC1+, uses approximately 17 megabytes. Care to guess how large the BF compiler is? Try 240 bytes. Yes, bytes. The C++ compiler I just mentioned is 1.7 times 10 to the 7 bytes. This means that BF can run on almost any system, regardless of size, and while it may not be useful, it is kind of beautiful. Alright, sorry for that tangent, I really do love BF, but back to the calculator. Coding in BF is pretty simple as, like I said, there's only 8 possible commands. BF has cells which store integer values 0 to 255, and you can add and subtract from these cells. If you want to learn more, I've linked a BF tutorial in the description. We take user input for the first cell, then again for the second, and add them together. It is really that simple. Before I end the video, the most common comment I saw was along the lines of, I could do better, or I'm gonna code even worse. I really like these comments. Not to get too sappy, but the whole reason I started this channel is to help encourage people to enjoy coding. And seeing that I could create a drive in people to get started on something, even as dumb as a bad calculator, was amazing. If you think you can do better than me, please do. Go out there, code a terrible calculator, make it as bad as possible, and I want to see it. I may not be the best coder, and I may also not be the worst, but I hope I can inspire you to become one or the other. I think now I can confidently say we have created the worst calculator ever. Our code is nigh unreadable and takes up so much time and memory. I can now rest knowing I've created the worst code possible. Thanks for watching. Drop a like and subscribe if you enjoyed, and join me next time where I create a phone that doesn't turn on. Why are you still here? That's the whole video. You can leave now.
Do it in assembly.
What? What was that?
Assembly.
What'd you say? Yeah, maybe next time.